Good afternoon. I'm Angelina Jamova. I represent Ukraine. Topic of my project is hardware and software complex for studying satellite television broadcasting signals. Most satellite television users face the problem of low quality of satellite TV signals reception. This manifests itself as lack of video and sound. This problem was solved by promptly monitoring the quality of satellite TV signals reception. So, there are two methods of studying satellite television broadcasting signals, software and hardware. So, it is important to consider that both methods have its advantages and disadvantages. The main disadvantage of hardware method is that it doesn't allow us to study the parameters of the received signal in depth, but it gives us ability to study the parameters of the received signal in real time. Talking about software method, it is important to note that it gives us ability to study the parameters of received signal in depth, but it doesn't allow to do that in real time. So the hypothesis is that using combined hardware and software method could ensure maximum measurement accuracy. In order to test this hypothesis, we first of all analytically calculated the power of the received signal and then modeled the operation of satellite TV broadcasting system on computer. It was assumed that the difference between the results of the calculations and modeling could be explained by the influence of the external factors on quality of the receiving signal. The practical part complex consists of hardware and software parts. The hardware part contains a reflector mounted on a locomotor mechanism, a low noise block, a digital signal analyzer, a receiver, and a TV set. This part receives the signal and amplifies it. The primary measurement of signal parameters is done by a digital analyzer. Then the signal is demodulated. During the modulation process, the signal level and quality are determined. After that, the signal is played back by the TV. The software element includes a satellite tuner, a computer, and a special software package. At this part of the complex, the signal is demodulated and its parameters are analyzed in detail. The signal spectrum and its modulation constellation diagram are visualized. The signal parameters are also measured. The transponder frequency is determined, and the available programs are identified. The demodulated signal is then played back. The components of the complex are connected by coaxial cables. Satellite splitters provide simultaneous signal supply to both parts of the development. Experimental tests of the created complex consisted of receiving the signal and studying its parameters with the created development. During the experimental tests, the reflector was tuned to a frequency of 11,817 GHz using a digital analyzer. Then the first measurements of the received signal parameters were made. After that, the receiver was set up and the signal power and quality were measured. The demodulated signal was played back on a TV set. Then we proceeded to a detailed study of signal's parameters on the software element of the complex, where we visualized its spectrum using the CrazyScan program, determined the transponder frequency, and visualized modulation constellation diagram using the TS Reader program. After the data was recorded, the signal was played back using the player software. We also confirmed the hypothesis about combining measurement methods. As you can see in the table, advantages of software method compensate disadvantages of hardware method, and vice versa. The received signal spectrum, visualized by CrazyScan program, includes the signal of the selected transponder and the signals of the other four. A number of the other signals which we detected were impossible to demodulate due to their low power. They were probably emitted by a telecenter located near the laboratory. So, these low power signals can clog the communication channel and cause low quality of satellite TV broadcasting signal reception. So, it confirmed assumption about influence of the external factors on the quality of the receiving signal. Rated development can be used for evaluation of the signal reception capabilities at a given location, selection of the signal reception location, search for sources of interference in the Ku band. To sum up, the possibility of creating hardware and software complex for studying satellite television broadcasting signals was confirmed by the results of the theoretical part of the research. The results of the practical part of the project confirmed the hypothesis of combining hardware and software measurement methods. The experimental tests confirmed the possibility of practical use of the created development. Thank you for your attention.